Hey, welcome back to Math with Patrick. Today is October 14th, and we're solving problem 287 from the Daily Epsilon calendar. And we should show why x is 14 for today, because that's today's date. Find the largest integer x for which there exists an integer y such that this equation is true. So, okay, it says integer, which means like whole number, positive or negative. But since it's asking for a largest integer, I'm assuming that there's going to be some kind of negative solution for this and some kind of positive solution for this, just because we're like squaring x and squaring y. But I think it's safe to assume that x can be positive because our final answer is going to be the largest solution. So if there is a negative solution and also a positive solution, the positive one rules out for this problem today. And basically what I'm seeing out of this equation is that we just have two square numbers here whose difference is 27. Because if I square this number and add on 27, I'll get to I think the next one. I guess one thing that I'm forgetting here is that like maybe as we count through our square numbers, maybe 27 could be the gap between like two square numbers that are 2 apart or even 3 apart. So I guess I should also double check that. So I think we should explore just gaps between square numbers, and also just assuming that our x and y's are positive, I think is fine for today. So when x is 1, the square of that is 1, 2, 3, 4, 5, 6, just to put on some examples on the screen. And the differences between these are 3, then 5, then 7, then 9. And essentially here we're counting by our odd numbers. So at some point, we are going to get to some square number that when we add 27 gets us to another square number. So we should probably figure out when that is. Let's see. We started at 3 and we went 1, 2, 3, 4 hops to get to 11. And we would need to go 8 more hops to get to 27. I just did like 27 minus 11 is 6, and dividing that by 2 is 8. So we would need to do 8 more hops to get to here. 8 more square numbers after the 6th one will be the 14th square number. So maybe I'll count back to like maybe the 12th square number. Maybe my like little estimation ideas were a little bit off. So I don't want to be I don't want to miss anything, right? So 12 squared is 144. 13 squared is 169. 14 squared is 196. And let's look at some differences between these square numbers. Here, this looks to be 25. So this is the 27 right here. That's kind of matching this 27 in our problem. So I guess y feasibly could be 13 and x could then be 14, such that once we do 169, that's the 13 squared, plus 27, we do get 196. But it does say, like, find the largest integer x for which there exists an integer y such that this equation is true. I still haven't proven this statement yet, because it is totally possible that another, like, 2 square numbers have this difference of 27. But let's think about it, I guess. Because, okay, if I try doing the jump, like, say, instead of a jump from one square number to the next, but to the next one, essentially I'm hopping 2 square numbers up, that difference is going to be even because I'm making 2 odd jumps. So any jump of 2 or 4 is essentially it's going from an odd number to an odd number or an even number to an even number. And so I'm never going to get this plus 27. Okay. So I can only make jumps of odd amounts, either 1 or 3 or 5. Okay. And if I am making larger jumps between the two, then I'll be able to create the number 27 out of 3 consecutive odd numbers. Actually, yeah, totally. That would be like 9 plus 9 plus 9. So that's this one right here. I'm like imagining giving 2 from the 11 to the 7, and that gets me 9 plus 9 plus 9. So there we go. We could do jumps of 1 square number to the next. That's this pair right here. We cannot do jumps of 2. And if we tried doing jumps of 3, we could get a gap of plus 27, and that's going to be right here. Right? Yeah, because 36 minus 9 is 27. So we do have another solution here where x is now 6 and y is now 3. But of course, 6 isn't the largest solution that we found. And if we try looking for any other jumps of 1, well, we're kind of out of luck because the difference between the next two square numbers is going to be 29, and then all the other ones are at least 29, and so they aren't going to be, well, 27. So I think that about cuts it. Because like if I tried doing a jump of 5, that would suggest that I have 5 consecutive odd numbers in a row that equal 27. And then they would, if they're consecutive odd numbers, they'd all need to average out to the middle one. And I'm not going to find any integer value for kind of that middle number, which I'm representing with x here. So the only time that I could find a different solution was when I have a jump of 3. That's right here. But of course, x was too small. Okay, I think that about does it. Again, there's another solution with like negative 14, I believe, and then negative 13. That's also going to work. But of course, negative 14 is less than 14. 6 is less than 14. And so 14 is our final answer. Okay, that's kind of fun. Thanks for watching. I'll see you tomorrow. Bye.